Assalamualaikum and good day everyone. Today we will continue our chapter 4, which is 4.7 planar graph. At the end of the class, you should be able to recognize a planar graph, use formula to find the number of regions in the planar graph and show that the two graphs are homeomorphic. Okay, let's see for the planar graph. A graph is called planar if it can be drawn in the plane without any edges crossing. So let's see for the example. We have the figure 4.7.1, which is the graph K4. We can see in the graph K4 here, it has the crossing edges at the middle of the graph. How we want to know the graph K4 is the planar or not? We need to redraw the graph. So we redraw the graph of the K4. If we can redraw the graph and it can see that there are no edges that crossing which each other, then the graph is called as the planar. So let's see, we redraw the graph K4. We see that the graph K4 can be drawn without crossing any edges. So we can conclude that the K4 is the planar graph. Let's see another example. We have the graph K33 here. The K33 here is the non-planar graph. Why? Because if we redraw the graph K33, there are no way to draw the graph without any edges that crossing. Alright? So let's see for the Euler formula. Euler formula is rarely used. So there are 4 Euler formula here, but no specific formula for the specific question. You just need to find out yourself which formula you need to use, which formula fit the question for you to solve that question. Since the Euler formula is rarely used in this chapter, so I just go through it quickly. Alright, so let's move to the homomorphism, which is Kuratowski theorem. The graph G1 and G2 are called homomorphic if they can be obtained from the same graph by a sequence of elementary subdivision. An elementary subdivision is an operation of removing an edge UV and adding new vertex W together with edges UV and WV, right? So in the homomorphism, we just add the new vertex or vertices to the graph without changing the shape of the graph. That's it. It's simple as that. Alright, so let's see, we have the graph G1 here and we have the graph G2 here in the figure 4.7.5. So we can see in the graph G1, we see in the edges AC. So in the graph G2, we have the edges AC here, but we can see that it has the additional vertex here, which is F, right? So if we want to find the path AC, we can find it by using CF to end the FA. Alright, so with this we just add the vertex F here to the graph and we see that the shape is not changing. So we can say that the graph G1 and G2 are called homomorphic because G2 can be obtained from G1 using elementary subdivision. That's it. So homomorphism is just simple like that. We just add the new vertex or vertices to the graph without changing the shape, then this is homomorphism. Alright, let's see the homomorphism and the planar graph. A graph is said to be non-planar graph if and only if it contains a subgraph homomorphic to K33 or K5. So this is the graph of K33 and this is the K5. If the given graph is the subgraph homomorphic to the K33 or the K5, just conclude that the graph is the non-planar graph. Alright, let's see for the example. We have the given graph G here. We see it has homomorphic since it's vertex here. So let H is the subgraph of the graph G. And we can see in the graph H here, we have the homomorphic. So the H is homomorphic to the K5. Since the shape is K5, we can see clearly shape for the K5 here. So we have additional vertex here. So we can say that H is the homomorphic to the K5. So the conclusion is the G is the G is the non-planar graph since it contains the subgraph homomorphic to the K5. So the conclusion is G has a subgraph H homomorphic to K5, hence G is non-planar. You just see the shape of the K5 or K33. If the given graph have the shape of the K33 or the K5, then the given graph is the non-planar graph. Okay. This is the comprehension for you to test your understanding. So I hope you do all the comprehension exercise. And I give you the answer for the comprehension for you to check the given comprehension. Okay, for the number 1, this figure is just example how to draw the graph. Okay, the answer is not unique. Your answer is also correct as long as you can draw without any edges crossing with each other. Alright, this is just example of the shape of the graph. You can change it. You can change it using your own creativity. As long as you can draw without any edges crossing with each other, then your answer is correct. Okay. This is the exercise for today. That's all for today. Thank you. Have a nice day.